Hello friends, welcome to Hydraulics and Hydraulic Machines class. In today's class, we focus on how the indicator diagram changes when we apply the acceleration pressure head or the acceleration effects that we will study in this. That will make us to understand how the pressures change during suction stroke and during delivery stroke. So let us go straight away into how the acceleration effect in suction pipe and delivery pipe changes the indicator diagram. So our focus is the effect of the acceleration on indicator diagram, right? Yesterday we have determined what is the acceleration pressure head. The acceleration pressure head in the suction pipe is Ls by G, A by As, omega square R cos theta. This is the acceleration pressure head that which we have derived in the last class. So when we have determined that, depending on that, when theta is equal to 0, that is at the beginning, basically. As theta is equal to 0, cos 0 is equal to 1, the acceleration pressure head is equal to positive and it is equal to Ls by G A by As into omega square R. Similarly, when theta is equal to 90 degrees, HAS is equal to 0, cos 90. Theta is equal to 180 degrees. HAS is equal to negative. It is equal to minus Ls by G A by As into omega square R. Same is the case for the delivery head also. HAD is equal to LD by G into A by AD into omega square R cos theta. Theta is equal to 0, that is starting of the delivery stroke. Then HAD is equal to positive, which is equal to LD by G A by AD omega square R. When theta is equal to 90 at the middle of the delivery stroke, HAD is equal to 0. At the end of the delivery stroke, theta is minus 1. So HAD is negative. So minus LD by G A by AD into omega square. So I wish to represent the same in the indicator diagram. So you already know what is an indicator diagram. Indicator diagram is a diagram wherein on x-axis we represent the stroke length and on y-axis we represent the pressure head. So if you draw like that, that is what we call it as the indicator diagram. So first, what we will draw the atmospheric pressure head. That is the practice. Then we will draw basically the ideal indicator diagram. Ideal indicator diagram previously I have given to you. This is how it. So it is AB, CD. This is EF. This represents H atmosphere. This represents H Yes, this represents HD, right? This is what ideal indicator. So during suction stroke, the suction head is constant. During delivery stroke, the delivery head is constant. So this is the suction stroke. This is the delivery stroke. Now what happens actually? So in addition to the suction head, because of the acceleration pressure head, in addition to the suction head, that also comes in picture. When it comes into picture, what will happen? For example, let us take at the beginning of suction stroke. That is when theta is equal to 0 degrees, right? That is what it is. Then at theta is equal to 0 degrees. Now what happens? What is the pressure head actually? The negative at theta is equal to 0. That means during suction stroke, in addition to the suction pressure head, there is an additional pressure head of what you call it as acceleration pressure head. And this, during suction stroke, the pressure head is basically the pressure head is less than atmospheric pressure. It is negative pressure head. Right now what happens? Previously it was hs. Now because of acceleration, this additional thing has come. This is has. But when theta becomes 90, as has is equal to 0, then naturally this is how it will be. Has is equal to 0, therefore total head is equal to hs only. But when theta is equal to 180 degrees, as HAS is negative, the total head is HS minus HAS because HAS is negative. So then how it looks like? This is how. So this is HAS. This total is what? HS. HS minus HAS. Now you see, instead of AB, now this line has changed to A dash B dash. So the indicator diagram, how it changes? Because of the acceleration pressure head. At the beginning, the total suction head is this much, right? Total suction head, that is better. Then at the middle, there is no effect. At the end, it is negative. That is what we want. Now we want absolute pressure head. If you see absolute pressure head during suction stroke, because it is negative, what is it actually? It is the H atmosphere minus HS plus HAS. This is what you should remember. This is H absolute. This is very, very important for us in next lecture. Then similarly, if you want during suction stroke, theta is equal to 0. Theta is equal to 90 basically. H absolute is equal to H atmosphere minus HS. And at theta is equal to 180 degrees, H absolute is equal to H atmosphere minus of, what is it? HS minus HAS. This is the thing. This is usual. So that means at the beginning, what is happening is the pressure is dropping down. Here, what is happening? Negative pressure is increasing. That means what is happening to the overall absolute pressure? The pressure is dropping. Here, this is crucial for us. Then, for example, if I take it delivery stroke, at the beginning, if I take it when theta is equal to 0, then basically what is the point actually? It basically it adds. It adds means actually the total delivery head is equal to that is HD plus HAD. That is the first thing. Then at theta is equal to 90 degrees, the total delivery head is equal to HD only as HAD is equal to 0. When theta is equal to 180 degrees, the total delivery head is equal to HD minus HAD. Right? So the finally, if I put the same thing here in the graph, actually, just see at the beginning it is addition, at the end it is drop. So now if I at the middle it is 0. So this is how it will. So instead of CD, it will be C dash D dash. Now what is the indicator diagram for us? Instead of A B C D, it will be A dash B dash C dash. So A B C D is the ideal indicator diagram. Whereas A dash B dash C dash D dash is equal to what is it actually? The indicator diagram considering acceleration effects. So this is the first thing. Now, if I see this diagram, only thing is here the pressure changes I could observe. But the area wise, if you see it, is there any change that you find in the area? There is nothing that in the area. So automatically, basically, there is no change in the work done. Conclusion is there is no change in the work done. Acceleration has no effect on the work done, no change on work done because the indicator diagram is same, so there is nothing. But what is the effect is pressure drops. Pressure drops at the beginning of suction stroke. Again, pressure drops at the end of delivery stroke. So these are the conclusions from it actually. So if I take it, so when acceleration affects, what will happen? Suddenly the pressure will reduce actually in the suction stroke and so these are the important points for us for our future study. So if you want actually, what is the pressure head? Pressure head considering the acceleration effect. First, let us take it suction stroke. Theta is equal to 0. What is the meaning of it? beginning of suction stroke, then total suction head is equal to Hs plus HAS. That means Hs plus Ls by G into A by As into omega square R. This is negative pressure. Absolute pressure is equal to absolute pressure is head is equal to H atmosphere minus of Hs plus Ls by G A by As omega square. This is very, very important. This is the reason where basically the maximum speed of reciprocating pump is controlled by this actually. Suppose second, if I take it, theta is equal to 90 degrees, then again total suction head is equal to Hs as HAS is equal to 0. Therefore, again theta is equal to 180 degrees. Total suction head is equal to Hs minus HAS, which is equal to Hs minus Ls by G A by As into omega square R. Delivery stroke. Theta is equal to 0 degrees, right? Then total delivery head is equal to HD plus HAD. It is equal to HD plus LD by G plus, sorry, A by AD into omega square R. Then theta is equal to 90 degrees. Total delivery head is equal to just HD as HAD is equal to 0. Theta is equal to 180. Total delivery head is equal to HD minus HAD. So that's why it is equal to HD minus LD by G into A by AD into omega square R. So again, this is a very big problem. These are the first one, beginning delivery stroke. So for the suction stroke, beginning pressure drops, whereas delivery stroke ending pressure drops. So these issues are very important. These two are very important for determining maximum speed of reciprocating. So here I will stop. So in today's lecture, we have completely discussed about how the acceleration effects changes the indicator diagram, and is there any change in the work done because of that, and what really is the importance in the indicator diagram, because the acceleration pressure head's importance is only the pressure changes. Where the mainly it is focused, where mainly it is focused is at the beginning of suction stroke, the pressure decreases. So that is one alarming point. Whereas at the end of the suction stroke, also pressure, at the end of the delivery stroke, also the pressure drops. That is also an alarming thing. So this is the important thing. However, there is no change in the work done because the area of the indicator diagram remains the same, whether it is horizontal or a little bit inclined, but the quantity is same on both sides. That total effect is nullified. With this, thank you very much. Let us meet in the next lecture.
Like, share, and subscribe. Hit the bell icon for more updates.